Hello, and welcome to CYBR in 10. My name is Nick Dulovitz. I'm the Director of Technical Alliances at CyberArk. CYBR in 10 is a video series consisting of 10 to 15-minute installments. Each video covers a single topic with the common theme being education around CyberArk specifically and privilege best practices generally. This session will cover CyberArk's Endpoint Privilege Manager with a focus on containing attacks on the endpoint. So there's a whole bunch of third-party proof points that we can pull from, like the Center for Internet Security, to illustrate the importance of controlling administrative privileges. Here we see it's a top 5 control, in fact, coming in at number 5 with a bullet, controlled use of administrative privileges. We're actually going to cover some other things that are in this top 5 list as well. One example being inventory of authorized and unauthorized software as we go through this discussion today. So going back to our idea about proof points here, we can see Gartner calling it out as least privilege. And what exactly is least privilege? Well, according to Wikipedia, the principle of least privilege requires that in a particular abstraction layer of a computing environment, every module, such as a process, a user, or a program, depending on the subject, must be able to access only the information and resources that are necessary for its legitimate purpose, right? So it should have the least rights that it needs to have in order to do what it's supposed to be doing. What that means in practice from a user perspective is when an application or service requires administrative privilege, the end user should log on as a standard user and privilege should only be elevated according to policy. So why? Why is that important? Well, we simply don't want users to be able to do things like change system configurations, enable or disable services, edit configuration files. We don't want users to be able to install malware, right? Even if that user is installing that malware on purpose or potentially not on purpose, right? Maybe maybe they got a spear phishing email, and in that spear phishing email, there's a link, right? They click on that link and they get routed to an external website. If that user has administrative rights on the system, which also grants that user the ability to install software, right, then now that attacker, right, who's gotten the user to click the link is able to execute that application, that package, as the user, right? So removing administrative rights means that our users are no longer able to make simple, silly mistakes like that. And then finally, of course, not allowing them to be able to access and change account information on the target system, not allowing them to do things like create backdoor accounts, right? And today we can see that 87% of organizations have not removed local admin rights from their end users. And why is that? Why have they not removed local admin rights? Well, it's actually really simple. It's very hard to do, or at least it's fairly hard to do. Why is it fairly hard to do? Well, there's a few reasons, right? First of all, users that have local admin rights, they can do whatever they need to do on their systems. They can install the application they need to install. They can make configuration changes that they think they need to make. But on the flip side, that means that there's going to be an increased number of security incidents. And it's really not about well, certainly the increased number of security incidents means additional overhead on the security team, but it's not about the increased number. It's about the one that causes the breach, right? So what happens on the flip side when we remove local admin rights without having a specific tool in place that allows us to facilitate that removal of local admin rights and facilitate those users being able to perform the actions that they need to perform? Well, it means an increased burden on the support team, an increased number of calls to the help desk, and of course, an increased amount of overhead from a cost perspective. From the security perspective, right, it means that we can contain attacks on the endpoint and reduce the number of attacks that make it off of that endpoint and continue to proliferate across our network and move laterally, right, get to higher value assets, which is critical to CyberArk's mission, which of course is protecting the heart of the enterprise. All right, so how do we go about fixing this? How do we go about helping customers and clients to be able to remove local admin rights, which I think at this point we've done a really good job of establishing that that's the right thing to do? Well, today we have tools that we can use to do things like detect malware on an endpoint system, right? And it's going to use things like behavioral analytics to do that. So does it walk like malware? Does it talk like malware? Based on those types of identifiers, we can reasonably, with reasonable confidence, say that, hey, this is most likely malware. Let's flag it. Let's stop it from doing what it needs to be or what it's trying to do. We have tools that we can use to perform patching, whether it's OS patching or application patching. There are many different tools out there that perform that functionality. The tool that isn't missing, because obviously the tool exists, but the tool that we think that there's still a lot of green field from a user adoption perspective are least privileged solutions, such as CyberArk's privilege or endpoint privilege management product. Which we can use to do a number of different things, but of course, at its core, it's going to allow us to implement a least privilege model, but still allow our end users to be able to perform the actions that they need to perform, to be able to do their jobs, and to be able to perform those actions in a transparent way. All right, so what does CyberArk's Endpoint Privilege Manager provide from a functionality perspective? Well, like I said, it does a few things beyond least privilege. Least privilege is at its core, but in addition to least privilege, it also provides application control functionality as well as credential theft protection. So let's go through a couple more slides here where we can dig into each of these. And I think we've done a pretty good job of covering least privilege, but it's the ability to remove local admin rights from business users, to control command line activity, and to segregate duties on Windows servers. So one example of this, so let's talk about how this actually works, right, or what the end user experience is like. CyberArk's Endpoint Privilege Manager is an agent that would get installed onto a target system. That target system in this case will be the user's workstation, as an example. We'll define policy centrally, and then that policy will get pushed to the agent that sits on the end user's workstation. That within that policy, there's a rule, as an example, that says when a user tries to execute this particular application, and this particular application in this case requires administrative rights, the user is going to execute the application by double-clicking, let's say, and then transparent to the user for that action, they'll be assigned an administrative token, which will allow them to elevate their rights for that one specific thing to admin or to the level of access they need to perform the action. The action will execute. It will look completely normal to the end user. There doesn't have to be any additional interaction. They'll be able to go ahead and do their thing and move on with their lives, right? Conversely, if that rule does not exist, but the application requires administrative rights, like let's say it's a situation where they clicked on that link in the spear phishing email and they got routed to some website where they're then prompted to have some type of code execute. That code execution will no longer be able to happen, assuming that, again, it requires those elevated rights, right? Because there's no policy in place allowing it. Moving on to application control beyond least privilege, application control can do things like block malicious applications from running. It can do things like elevate privileges for authorized applications, like we talked about around privilege management. And then it can also streamline application control policy definition using application risk analysis. So if we were to dig into to this a little bit more, let's talk about where we have a situation that maybe a user has the ability to install a particular application because that application does not require administrative rights, right? We've gone ahead and we've implemented least privilege. We've removed administrative rights from our end users, but then there are still applications that don't require admin to run. So one example just would be like the Spotify client. Maybe you as an organization don't want your users installing the Spotify client on your endpoints, but of course there's no way to block that from a pure Windows perspective because it doesn't require administrative access. With CyberArk's application control, we can actually block that particular application, right? So we can disallow them from being able to install Spotify or any other application on that endpoint. And then finally, credential theft protection. This allows us to detect and block suspected credential theft attempts, either from the operating system or the browser. Where you have a situation where the browser pops up and asks if you want to, remember a password for a particular website, and many users will say yes to that, right? Well, that secret store that the browser is leveraging is not very well protected. So CyberArk's Endpoint Privilege Manager can actually add an additional layer of protection on those secret stores, so that if an attacker does try to exfiltrate secrets from that store, we'll not only detect it, but we'll actually block that particular attempt. So that's another piece of functionality that exists within CyberArk's Endpoint Privilege Manager, or EPM, we like to call it. So an important piece of this is that it's generally fairly difficult to define policy that's all-encompassing for a solution like this. So CyberArk has a relatively clever approach via the way that we can define particular software to be trusted. So we can do things like based on where the software is being distributed from. If you have like an internal SCCM server or internal software distribution solution, we can actually trust that software distribution solution so that anything that comes from there, we're going to go ahead and say, hey, this is okay. We can also define that as particular network shares within your environment. You can define specific shares where you can host software, and as long as a user installs from that location, we're going to go ahead and allow it. Beyond that, of course, we can look at digital signatures on the application itself. And then finally, what we're going to be left with will be just a few different things that we need to make manual decisions on. But generally, what we'll see is the vast majority, right, over 99% of your applications are going to be handled by our sort of more automated policy creation type activities. So let's talk about application risk analysis. So let's say that we've got an application that we don't have a rule on, right? So there's an app that we're not sure what to do with. You know, where should we, or not where should we, but how do we make the determination whether or not the software can be trusted or whether or not it should be flagged as malicious. So first of all, we can integrate with different third parties. So whether it's Checkpoint, FireEye, Palo Alto, or VirusTotal, we can send application samples to any of those parties, and they can run an analysis and then let us know if these things are okay. So if your client leverages any of those technology solutions, we can go ahead and send that application information over to that appliance to be analyzed. Additionally, if it's something that we're not sure what to do with it, even after the analysis has been done, or maybe we aren't leveraging the analysis for one reason or another, let's say that it's something that we don't know what to do, we can let it run in a restricted mode. So a great example of where this restricted mode or gray listing comes in really handy is around ransomware, right? So with ransomware, it's going to try to do a few things right away, right? When ransomware executes, it's going to try to connect to the internet to pull down additional encryption keys. So because the more keys it can use to encrypt your data, right? So it's going to use one key on one workstation, a different key on a different workstation. That means you're paying multiple ransoms. You're paying a ransom for each of those keys. So they're able to get more money from you if they can connect to the internet and pull down more encryption keys. Additionally, of course, it's going to need to be able to read or write to the file system to be able to perform any encryption. So with gray listing, what we'll do is we'll say, hey, we're going to allow the file to execute, but we're not going to let it really do very much once it's executed. We won't let it read or write to the file system, so it can't encrypt anything. We won't let it connect to corporate file shares or removable devices. And we're, of course, not going to allow it to connect to the internet, so it can't pull down additional encryption keys and get you paying more ransoms, right? So that's another methodology that we have in place within Endpoint Privilege Manager to help to lock down controls within your endpoints. And then finally, when we talked about credential theft detection. This goes back to, again, as we've talked about in a number of these videos, the idea of thinking like an attacker, right? And one of the first things they're going to try to do, because it's very easy to do and it's going to give them additional access to resources, is once they get onto a target system, they know that many users go ahead and say yes when that browser pop-up window comes up and says, hey, would you like me to save this password for you? So one of the first things they'll do is they'll check to see if they have local admin. And then if they do, they're going to try to go ahead and steal from these credential repositories. Some of them require local admin, some do not. One example that does require local admin is dumping the LSAS on a Windows system, right? And the LSAS is a place where that is running in memory where we can pull credential information from, right? So if you can dump the LSAS, you can then potentially pull credentials from there after the fact. Additionally, even without having local admin rights on our systems, those attackers would be able to potentially pull credentials out of our different browsers. And CyberArk has a layer that is monitoring and will alert and, of course, also block when an attacker tries to do that if credential theft detection and blocking is enabled. From an architectural standpoint, the solution does leverage a client-server model, and it can be installed either in an on-prem, so whether that's within a client's brick-and-mortar data center or a client's cloud environment. It's also offered in a SaaS model where CyberArk hosts the server side. Clients will manage their own policies by logging into CyberArk's web portal in order to manage their particular endpoint privilege manager environment, and then the clients will be deployed based on their standard client software deployment mechanisms within their environment. So in summary, we're going to remove admin rights and invisibly elevate privileges for trusted applications. We're going to allow users to run unknown applications in restricted mode, and we're going to protect against credential theft for any applications that are running. All right, thank you for watching the video. If you liked it, go ahead and hit like and subscribe. If you didn't, please let me know how we can make these videos better in the future. I appreciate your time, and have a great day.